So our last presentation is Dr. Aitazaz Farooque from, he's a professor and director for the Center of Excellence in Food Security and Sustainability at UPEI. I think most of you probably know Aitazaz or have heard him before. His research focuses on state-of-the-art precision ag technologies for Atlantic Canadian agriculture. Aitazaz was selected as one of the top 125 researchers in Canada to receive the NSERC Discovery Accelerator grant. He's currently supervising 13 PhDs, 16 master students, and 4 postdoctoral fellows, and then a bunch of research associates and undergrad students. He's been very involved in a lot of projects with us at the Potato Board, and he's going to be sharing some of those today that are kind of co-funded or co-sponsored through either our AIM project or through Potato Board work. He's a registered engineer, professional engineer here in PEI and in Nova Scotia, and also very recently a professional agrologist in PEI. So take it away, Aitazaz.
Thank you, Ryan. Good afternoon, everyone. So as Ryan mentioned, I'm going to give a bit of an overview of some of the precision ag work we have in collaboration with the board and with other funding partners. And let's get on it. And all right, so Ryan and I chatted and we picked on 4 projects which Ryan wanted me to present. So this is why you will see, and I'll give an overview on those 4 projects. For some reason, this is not moving. Yeah, so the first project I'm going to talk about is the potato virus Y. So we have developed a robot to pick on the potato virus Y, and then variable rate seeding, followed by a bit on the compaction, and then a little bit at the greenhouse gas emissions. Where should I point this?
You can point it anywhere. Just you have animations in your presentation, so whenever you press it, the animation will play.
Okay. Yeah, so these are the 4 projects I'm going to bring. And so the precision ag, which is my research area, so it can be linked with many sustainable development goals, but I do feel like SDG 2 and 9, they are the best suited. I'm not going to repeat the definition of precision ag because the speaker before, so they have covered it. It's basically managing the variability within the field to optimize the profitability. So let's get into it, potato virus Y. So I know the majority of the audience in the room are growers, so I don't need to tell them the symptoms of PVY. I'm sure they are very familiar. But at the end of the day, it is damaging and reduces the yield. So that's the bottom line. And we need to find ways and solutions to actually control that. So some of the symptoms which are presented on this slide, so I borrowed those images from Matrash from New Brunswick, and those images are, you can have PVY, PVYN, NTN, and there are a few based on the strains, so the idea was to pick on the viruses. So what are some of the current methods to deal with the PVY? So it's mainly roguing. Trained rogers would go in the field. They will inspect, scout, come out, and pull those plants out. So this is how it's been done. So now in this project, the idea was to employ machine learning and artificial intelligence to pick on the PVY. So that was the main, and so that if we can pick on the evolution of the symptoms within the fields. So we started off with some of the greenhouse images. So again, Matrash and Potato Board New Brunswick were able to provide those images because Matrash is a guru of precision, this PVY as in Atlantic Canada and North America. So we got those images, so we did some initial sampling and categorize what is what. So you can see the control image, which is healthy plant, PVY-O, and an NTN. So those are the 3 strains we focused on. And then we had the training data set, we had validation and testing data sets, so where we knew that there are healthy plants and infected plants, and we labeled them on what is what. So then using the machine learning model, so we classified that data and divided into different data sets to basically differentiate what is what. and then trained our models and validated those models to see how accurate we are, how accurately we can pick on the PVY based on those images. So in the first iteration, so we had all 3 strains of PVY, and it is a messy graph you can see. So this is how the machine learning model works. It starts memorizing and learning about the logic, and sooner it kind of memorizes and then it gets stable a little bit. So in this particular case, so we had 4 categories, PVY-O, N, and NTN, and then when we ran the model, so our accuracy was 65%. So now the question was, for me as an agriculture engineer, so I'm not an agronomist or pathologist, for me PVY is PVY. So then we thought, let's divide that into 2 categories, infected versus non-infected, and see how the model performance go. And so in this case, we divided and ran the data set for 2 cases, and the model accuracy improved to 85%. So that gave us a bit of an initial idea that there is a room and opportunity for us to actually explore this, because there is an option and opportunity. Anyway, so this is the accuracy. So do you guys remember from the COVID early days, false positive, false negative, true positive, true negative, all those tests? So this is how machine learning works. Sometimes it will pick on the target which is not right, and this is how it is false positive. And you can see this confusion matrix, so where you can see there are 3 images which were wrongly detected, and in infected there were 9 images which were wrongly detected. So this is how it works. So then we went straight into the field. So we developed our robotic system. So this is a screenshot of that. So some of the evolution of that robot, so how that it came into existence, you can see from the frame and electronics and whatnot, and some lab testing. So it has basically 4 components: machine vision. It is battery operated robot. It can run for 8 hours in a day with 1 battery. We can replace that battery. And the speed can range from 4 kilometer up to 18 kilometer per hour. So that's the, and then it has RTK GPS enabled, and it is operated by remote control. So this is one of the video when we were inspecting a research field at Cavendish Farms. And you can see it can cover 3 rows. It has 3 cameras. We use cellular cell phones. By the way, I got questions by procurement why I'm buying cell phones using research dollars. And then we had the cellular service, and idea was to upload those images right away to our server so that we don't have to download or anything and processing. Here is another video. This is from New Brunswick, from Matrish. He has a big trial where he has a lot of symptoms for PVY, and we wanted to capture all kind of evolution in the symptoms. Overall, in the season, we collected over 80,000 images and videos. We labeled about 9,000, and then the idea was to classify those models. So here are some examples where the infected versus non-infected plants are. And again, we divided the data into training, validation, and testing, and using the standard protocols. And then we trained the model, and we figured that our accuracy when we differentiated between the infected versus healthy plant was 75%, which is a good start based on a year data, okay? And we will be collecting more images and data this year, and we try to do all the imaging in the early morning, late evening, mid-afternoon, early afternoon, cloudy, partially cloudy, sunny, all kind of possible combinations, so that our model and neural network has that logic in the brain that it can capture. So some of the challenges based on the year 1's really sunny conditions were a little bit misleading and causing the issues because it was too sunny, but under cloudy conditions, the images were perfect. This year, we plan on maybe adding a bit of a shade or whatnot to see if we can have more consistent images to increase our accuracy. So we got the accuracy about 75%. The greenhouse accuracy was 85%, but we are aiming that if we can touch 90. I'll be really happy if we're close to 90. And I remember Ryan said last time, maybe the Roger cannot pick with the 90% accuracy. So we'll see. So we'll have those images done. So this is a work in progress, as I said, so we will be collecting more images and building on that. And this year, we will be adding RTK module to it. and that RDK module, what it will do for us, it will bring a map of PBY infected areas. And then anybody can download that map, put on the cell phone, walk to the field, pull those plants out. So that's the concept. The second topic, which I'm gonna very briefly touch on, is the variable rate seeding using SWOT maps. And majority of this work was done by PhD student Evan McDonald, and I'm just gonna give a bit of a summary on that. So from 2021 to 2023, we had 10 fields in PEI where we performed the variable rate seeding based on the SWOT maps and variability. And based on that, we varied the spacing about 10 to 15%. We have collected 330 strips from the potato fields to actually look at the economic analysis and economic trade-off if we go one route over the other. So the rationale behind, we looked at a couple of papers from Europe and Netherlands that the variable rate spacing and seeding can potentially generate some more revenue, ranging from $93 up to $278 per acre. So we wanted to explore that if that is true for Prince Edward Island, and that was the rationale behind. So then based on the spacing, we did use drone technology to verify whether the spacing was right, or we were relying on the mechanical and kind of hoping for the best. So we did some physical measurements and also have the drone images to actually look at the spacing, and it was about 95% accurate that the spacing was done right. So the idea here was that we are in the weaker parts of the field, we spaced the potatoes out a little bit, didn't put them tight together, but we're in the highly productive areas, we went with a little bit of a tighter spacing. And then in the medium zones, we went with the status quo, which was the grower standard practice. So this is a bit of a summary where the wider spacing zones in upper zones, drier areas, outperform the grower standard practice 5 out of 9 times with about $90 per acre. So that was the summary. So then in zone 3, which was a tighter spacing, when we evaluated and crunched the numbers, what we found that the tighter spacing in lower zones, more moisture but well drained, they outperform 7 out of 10 times with average profitability of about $360 per acre. So that was the comparison. So we do have a lot of drones at the center in the lab, and we use that for multiple purposes. So this is just a drone image collected to count on the emergence rates and the plant canopy and cover in different zones, and correlated and overlaid over the SWOT zones to see how things are going. So just to kind of summarize on the seeding, so the percent acres of the variable rate seeding, if a farmer can do about 40%, there is about $90, $50, $60, so you can say from $90 up to $134 per acre, that's the profitability you can expect. Planter is needed, which is capable of reading that variable rate planting, and then displaying a map, which is a prescription file, and a software. So these are the 3 major components to actually perform the variable rate seeding. The third project I'm gonna briefly touch on. I need to be mindful of the time. I would like to close at 12 because I have to be on a Zoom meeting right after. But so the compaction, so this is another project which we started a couple of years ago. We have scanned a few fields, and Ryan and my team has been heavily involved in this project like others. And this is from 2023. We had 2 fields, and then we SWOT mapped those fields at the same time. We mapped them with the dual EM sensor. And then these are some of the images when we were taking the compaction measurements and detecting those compaction methods and whatnot. And some measurements, and then bulk density and moisture and all kind of data which was done analytically in the lab. So this was a bit of a summary when we correlated the compaction with the conductivity. So our accuracy was about 60%, and you can see in low profile, in the soil profile, you can see the variation in the soil moisture and temperature. So we collected all that data to correlate and see how things are behaving. Is it really compacted? Our sensor is giving us the wrong reading. So that was the idea. Again, we did some GIS analysis and look at the resistance in different layers and whatnot, and the idea was to have a compaction map. And that map, at the end of the day, we would like to use, if we can, for the variable rate tillage, so that we can break the hard pan and provide the better growing conditions. Again, from 2023, thanks to Andrew Frazier, sometimes I bother him too much. I asked him I need the new data to be included in the presentation, and he analyzed that data for me. So again, this is the conductivity map and some of the low, medium, and high compacted zones, and you can see the resistance, and they are quite variable. So it's not the consistent. And the idea was to look at, and these are the 3D maps. Like we can fraction off the response to top 10 centimeter, 15, 20. And the idea was to see, because based on my conversation with the growers and Ryan and other stakeholders, that anything below 30 centimeter, that's really hard to manage. So we want to stick ourselves to the root zone so that if there is a hard pan, we can break and produce the. So this is again work in progress. We will be collecting some more data this year, and we are looking into the equipments and the manufacturers that if they have the capability and we can get the data from their data servers and control systems to actually weather the power usage in certain areas and whatnot, and that can be overlaid over the compaction map to see what's going on. Last project I want to shed a little light on is the greenhouse gas emissions. So at the center, we are looking into different kind of strategies to monitor and evaluate greenhouse gas emissions as a function of several strategies and management practices under cover crops, different cover crops, under potatoes. And to me, the way I see it, when this carbon business is regulated, so it will be really useful to see what is the carbon footprint of a 2-year production cycle versus 3-year, and how that trade off and where that balance off. And I think it is a good thing to quantify and promote sustainable agriculture practices. So again, some of the images. So we do have the LICOR meters, which I think we are the only one in Atlantic Canada, at least, who have access to do state-of-the-art meters. And I know Agriculture Agri-Food recently bought one, and so I don't know whether that arrived or not. But those are pretty slick and efficient to measure the greenhouse gas emissions in situ. Obviously, we did calibrated them with the known concentrations so that what we are proposing is really accurate. Some of the images during data collection again, and so then at the end of the day, we would like to build a model that it takes into account the weather data, it takes into account the soil, and all the variables to basically come up with an emission matrix and see. So on the right-hand side, so those are some correlation coefficients between soil moisture, temperature, and several other variables to see whether those variables are influential on what kind of role they are playing in the whole this emissions business. So this is one of, I'm really at the tail end of it. So we use, again, machine learning and artificial intelligence models to model those emissions, and where we compared the measured versus predicted, and our accuracy was about 90%. And on the right-hand side, you can see the carbon dioxide flux measured versus predicted, and you can see the values are fairly close. And some more on the nitrous oxide emissions and some of the, so we are in the process of developing a couple of papers which will be published in the peer-reviewed journal out of this study very shortly. Some take-homes. So at the center, in collaboration with many partners, with the Ames Group and Potato Board, we are developing climate smart and precision agriculture technologies, applying seeds and inputs based on that to see what are the profitability and environmental trade-offs, evaluating and promoting those BMPs through effective outreach, and what our aim is to develop the practices which are user-friendly so that they can be adopted quickly, and at the end train highly qualified personnel. So I would like to acknowledge all the funders for their generous support, and I would like to acknowledge Precision Agriculture Research Group at the university and my wonderful students. Some of them are here, for all their help and support during the data collection. Potato Board, Prince Edward Island, AIMS for the funding, ACOA and CERC, and various other funding partners for their support. At the end, thank you all for listening. I know I rushed through the slides because I got like 20 minutes to wrap up, but I'm really on time. Thank you very much, and I can take any questions you might have.
Questions for Aitazaz? I know there's a lot, we're doing a lot of projects together, and there's a lot, we're covering a few different buckets of things, but it's been a really good partnership, and we're also training hopefully a lot of students that are also going to be available to work in the industry as well. Any questions before we go? Gotta be at least one.
For the roving robot, is the plan to commercialize that somehow, or to make it available for growers?
Yes, it will be commercialized. We would need a year or two more data. I posted a video on LinkedIn. I got reached out by a couple of big players, and they're really interested to take it on. And I told them we're not there yet. Yes, there is a plan that if we can make it commercially available to make an impact for the industry.
My question is, it's a robot question. When you're evaluating the mosaic characteristics in plants, do you change or can you change the color of the lens as the light changes? There's no problem roguing on a clear day, on a cloudy day, but there is a problem roguing on a very sunny day. So can you change the different shades of lenses that as the sun changes, can the robot pick something like that up?
Yeah, so what I think when I said that we captured all kind of images and videos under different sun angles and rotations and whatnot. So what we figured, yes, it is due to reflectance in a really sunny day, so sometimes but we are planning to add a shade and use the cameras, which are really not very expensive because I'm not a big fan of developing a technology which people can't afford. So that's why I would like to stick with the solution which is more, I would say, economically viable. And but your point is right. Yes, there could be some changes in the lenses and some alterations to that to make it a little bit more effective.
No other questions? Thanks a lot. That's it.
Thank you, Ryan.
We have a meeting to get to.
Yes.
Thank you very much. Appreciate it. So that takes us to the end of our conference.